Hello everyone, this is Nitya, Assistant Professor, Department of ECE. This semester I am going to handle you real-time systems. It is one of the professional elective subject and this subject code is 18 EC 731. So this is the subject code. Okay, so first we are going to talk about what are the things which is there in this real-time system, what we are going to talk the entire syllabus, okay, and what is the objectives of the subject, and at the end of this course what we are going to learn, the students what they are going to learn. So all those things we are going to talk about in this topic. So the first, when we come to this, the course learning objectives, what is the objectives of the subject? Okay, so the objectives of the course is to enable the students to discuss the historical background of real-time systems and its classifications. So here what we are going to talk is, so what are the historical backgrounds of real-time system and what is the real-time system, the definitions of real-time system, what are the types of real-time systems are there, how it works, and what are the classifications of the real-time systems. So all those things we are going to discuss. Okay, and the second objective of this subject is describe the concept of the computer control and hardware components for real-time applications. So we know that when it is operates in a real-time application, then we need a computer. So if we are using a computer, we need to control the things what we are going to perform. Okay, if it is not controlling, then that system possibility of failure may occur. Okay, so and the hardware components of the real-time applications, when we are using a computer system, and hardware things which is also required because to measure the things, because it is related to the real-time applications, so the sensors like that, the hardwares and all which is required. Okay, so that we are going to connect into the computer systems. Okay, so the second objective is nothing but describe the concept of computer control and hardware components for real-time applications. And the third thing is discuss the languages to develop the software for real-time applications. So here one of the unit we are going to discuss about the applications of the real-time system by using a software. So the Photon software, by using that we are going to develop some kinds of software. I mean, by available software we are going to write a program for this particular application. Okay, and explain the concept of operating system and RTS development methodologies. So here we are going to talk about the different kinds of methodologies we are going to talk about. Okay, concept of the operating systems are also there. Okay, so these are the objectives of the real-time systems. Okay, next, when we come into the syllabus, the module 1, what we are going to discuss is introduction to the real-time system. So what and all we are going to discuss in this real-time system introduction. So in this there are two units are there. So the first unit is introduction to the real-time system. So here we are going to discuss about only the basic things of real-time systems. So the historical background and the introduction, what is a real-time system and what are the elements which is connected to the computer control systems, and the definitions of RTS system. So how the RTS will be defined, okay, with respect to the different systems, okay, and classifications of the real-time system, time constraints, and classifications of the program. Okay, so the time constraints is nothing but it must operate based on the timings. Without if it is not based on the timings, the system may face a failure. Okay, so how the timing constraints which meets in the real-time applications and the classifications of programs. So we know that when it is working in a real-time system, we need a program. So what kind of programs are there? Classifications of the programs are there. So the all those things are basic things, very much basic introduction to the real-time systems. And the second unit which we are going to discuss in this module 1 is the concept of computer control. So here we are going to discuss about the introduction, the different types of controlling we are going to talk about in this unit. So the controlling is like the sequence control, loop control, supervisory control, and centralized computer control, and the hierarchical systems. So all those things we are going to talk about. If it is on sequential control, by taking one of the example how the sequence control operations are takes place. Like that we are going to discuss in this unit. Okay, so I'll tell you what are the reference books and textbooks are there. In the textbook, these units, the unit 1 and unit 2, that is the module 1 entire chapter which covers from 1.1 to 1.6 and 2.1 to 2.6. okay, and the BT level which is comes under L1 and L2. okay, so this is module 1. So in module 2 we are going to discuss about the computer hardware requirements for real-time applications. Okay, so in that what are the things which we are going to discuss here? So we are going to discuss about the introduction and general purpose computer and single chip microcomputer and microcontroller, specialized processor, process related interfaces and data transfer techniques and communication and standard interfaces. So here what we are going to talk is the requirements of the hardware. So it is when it is connected to the computer system, what are the requirements, hardware requirements for the real-time applications. Okay, so that we need a computer. Okay, and for that computer there is a microcontroller and also a microprocessor, and there is a processor, and if it is on processor there is a interfacing between the one to another. So what are the kinds of interfacings are there, and how the data transfers between the one to the another place, and the communication, how the communications which is transfers from one place to the another place, and what are the standard interfaces which we are going to use in this. Okay, so all those things we are going to discuss in this unit. Okay, so in the textbook those topics which covers from the 3.1 to 3.8, and then PT level which comes under the L1 and L2. okay, so this is all about your module 2. And module 3, it's languages for the real-time applications. Languages for real-time applications. So what we are going to talk in this, languages for that real-time application. It's language is nothing but it is nothing but a software. Okay, so here we are going to talk about introductions of that particular language and the syntax and layout and the readability and declaration and the initialization of variables and constants, modularity and the variables, compilations of modular programs, data types, control structures, exception handling, low-level facilities, coroutine, interrupts and device handling, concurrency and real-time supports, and overview of the real-time languages. Okay, so the overall what we are going to study in this unit is some of the language we are going to talk. So syntax of that particular thing, and how to declare the variable, how to declare the constants, and how to declare the modularity, and what do you mean by the variables, and how to compile that particular thing. It's a modular program, and what are the data types are there, and how to control the structure and overall structure. So what are the control structures are there, and how to handle the exceptions things, and if there is any low-level facilities are available, and the interrupts and the concurrency. So overall real-time supports. So all those things we are going to talk in this module 3. Okay, and when I come to this module 4, it is on overall operating systems. So I think so some of you are studied last semester the operating system as an elective. Okay, so here what we are going to talk about is, so the same concept which we are going to discuss here, but based on real-time applications. So okay, so already we have discussed about the scheduling strategies, priority and task managements, everything we discussed in the operating systems. Okay, so now what we are going to discuss in this unit is, with respect to the real-time operating system, how the scheduling strategies which work, how the priority which are assigned. So all those things which we are going to discuss in this unit. Okay, so here we are going to talk about introduction, real-time and multitasking operating system, because we know that if it is on real-time there is a multitasking operation, so the multiple tasks must be handled. Okay, how with respect to the real-time operation the multiple tasks are handled by the operating system, and the scheduling strategies, so the different types of schedulings which we have talked about, in that how it will be covered. Okay, and priority structure, which is the highest priority, the which already when we are designing the program or the task itself, we need to assign the priority, we need to give the priority to each and every task. So based on that the priority structure will be assigned. And then task management, how the task will be managed, and scheduler, real time clock interrupt handler. So if there is any interrupt which comes, how that will be handled. And memory management, we know that in operating system the memory is one of the important thing, because all those things need to be stored in the memory. Okay, so how to handle that memory operations and all. Okay, code sharing. So we know that the one code which will be shared by the multiple programs in sometimes, how the code sharing which performs, and the resource control. So we know that with a less resource we need to cover entire operations. So how the resource will be controlled. Okay, and task cooperations and communication and mutual exclusions. So these all those things which we are going to discuss in this module 4 operating system. Okay, so in textbook which covers the topics which is from 6.1 to 6.11, and the BT level which is come under the L1 and L2. Okay, so this is all about your module 4. And module 5, designing of RTS and general introduction. So in this unit, in this module also, there are two units are there. The first unit is the general introductions about the designing of real-time system, how to design the real-time systems. And second one is we are going to discuss about the different types of methodologies. Okay, so the designing of real-time system and the introduction about the introduction of the real-time systems, I mean the designing of real-time system, and the specification documents, preliminary design, single program approach, and foreground and background systems. So these all those things we are going to discuss in this designing. Okay, and RTS development methodology. So in that we are going to discuss about introduction, Jordan methodology, Warden-Meller method, Hartley and Pripai method. So these all those things we are going to discuss in this RTS development and methodologies. Okay, so this entire module 5 which covers in the textbook, which is from 7.1 to 7.5 and 8.1 to 8.2 and 8.4 and 8.5. So these are the topics which you have to study when come under the module 5. Okay, so when I come to this BT level, the BT level which falls under L1, L2 and L3. Okay, so this is all about your syllabus, and these are the references. Okay, textbook, the real-time computer control and introduction, Start Bennett, and the second edition, Pearson Education 2005. So this textbook which covers the entire topic, all the 5 models which covers in this textbook itself. If you want to go beyond that, if you want to go study in depth, you can go for this reference book, Real-Time System Design and Analysis, and also the real-time system development and the embedded system. So you can refer this also. So these are the reference books and textbook. So whatever which is mentioned in the syllabus previously, the textbook topics from 2.1 to 2.4 and 6.1 to 6.4, that is textbook. So in this book, real-time computer control and introduction, so in this book which covers the entire model, okay, which is available in the library, you can take it. Right, so this is all about your the syllabus. Okay, after studying all the modules in this real-time operating systems, okay, what is the outcome of this particular course, particular subject? Okay, so at the end of the course, the student should be able to understand the fundamentals of real-time system and its classification, because in unit 1 we are going to talk about the real-time systems and the basic things, what is a real-time system, historical background, definitions, and how it will be classified. So everything we are going to talk about. So understanding the fundamentals of the basics of the real-time system and its classifications. Okay, and second thing is understand the concept of computer control and operating systems and the suitables. Okay, so in first unit itself we are going to talk about the computer control and operating system, which comes under the module 4. Okay, so here we are going to talk about, I mean by outcome 2, course outcome 2, the students able to understand the concept of computer control, operating system and the suitable techniques. Okay, so which is the students are studied in the model 1 and also a model 4. Okay, and the third thing, computer hardware requirements for real-time applications. Okay, so here the hardware requirement, it isn't the understanding the concept of computer control operating system and is the suitable computer hardware which is requirements for the real-time application. So what are the hardwares which is required? So that things talking about in module 2. Okay, so the students come to know that also. And the fourth one is develop the software languages to meet the real-time applications. In module 3, we are going to talk about the softwares. Okay, some of the syntax, how we are going to control that particular thing by using a programming language. Okay, so students able to develop that particular programming languages. By using that programming languages, they can design it. Okay, and the fourth one, last one is apply the suitable methodologies to design and develop the real-time systems. So because in module 5, we are going to study about how to design the real-time system by using the methodologies. Different kinds of methodologies we are going to talk about. So by using that methodology, how the students are able to design that particular thing. Okay, so the procedure is also given in the first unit of module 1, module 5. Okay, so these are the outcomes of this particular subject, real-time system subject, right? So this is all about your syllabus introduction. Now we are going to get into the unit 1, the first unit, introduction, module 1, introduction to the real-time systems. So I told you that in this unit, in this module there are 2 units. So the one unit is introduction to the real-time systems and second unit is the concept of computer control. So in introduction to the real-time system, we are going to talk about the historical background, elements of the computer control system, RTS definition, classifications of the real-time system and time constraint and classifications of the program. All those things we are going to talk. And the second thing is the concept of computer control. So here we are going to talk about introduction, sequence control, loop control, supervisory control, centralized computer control, hierarchical systems. So these are the things which we are going to talk about in this module 1, right? So yes, first we are going to talk about the introduction. First topic, introductions of real-time systems. See, actually the real-time system, it is nothing but the any system in which the time at which the output is produced is significant. Okay, so any system in which the time at which the output is produced is significant. Actually, the real-time systems are those which must produce us a correct response within a specified time limit. That is the main thing in real-time system. So whatever the output which is producing, that must be produced within a given time limit. That is called the real-time system. Okay, so the origins of this, the term real-time system, which is unclear where exactly which will be developed. It's not a clear thing, but it was probably the first used either with a project, the whirlwind, a flight simulator development by the IBM for US. Okay, so the first, the real-time system which was developed by the IBM in the United States. Okay, and in Navy in the year of 1947. Okay, so the semi-automatic ground environment air defense system developed for the US and Air Force in the early 1950s. Okay, in addition to this, the flight simulator developments, the wind control. So in addition to this, using of the memory and also a high order languages, programming languages, which compiler that produces that predator with the photon. By using this photon languages, the memory and all those things are controlled. Okay, and in 1960, the rapid development of this system which took place. Okay, as a significant non-military interest in the real-time problem solutions by using that real-time systems. Okay, so with this we are going to talk about the basic computer architecture, because everything which is controlled by using the computer system, we know that. So what are the basic computer architectures which we have? So we know that in the computer system have three basic components. What are the basic components which we have? The central processing unit, memory, and also a input output. So we know that input output is nothing but it's like on printer or terminal, or it may be on modem. Okay, so that input which is taken from the multiple inputs, one or more inputs entering into the block, into the particular input devices, and the same thing which can be produced at the output of that particular box. Okay, so the box is nothing but what they are telling us, it is a device. Okay, so the multiple inputs can be takes place and multiple outputs can be takes place here, and from the inputs, so all those things are interconnected, input, output, and then memory and the central processing unit. By taking the input which is stored into the memory, and the processor which performs the operations which is based on the requirement. Okay, which is based on the requirement. So everything which is interconnected. So in between this input and the memory, there is a the input and then central processing unit, there is a interfacing devices, that is which transfers the data and also a address bus, address signals. Similarly, from the memory, the central processing unit to the memory, there is a interfacing. So there is a interfacing device which is used to carry or control the informations, the data, and then address kinds of informations. Right? So this is all about your basic computer architecture. Next, we are going to talk about the historical backgrounds of real-time systems. Okay, so in earliest proposal to use a computer operating system in real time as a part of the control system was made as a Braun and then Campbell in 1950. He was the first person to develop the control system for the real-time applications. Okay, and it shows a computer in both the feedback and also a feed-forward loop. Okay, so this is the diagram, the earliest diagram of the real-time applications. So if you can see here, in the feed forward and also here the feed back, both the in both the sides there is a computer. See here also there is a computer, the signals which is passed through here, and here also there is a signals. Okay, so this was implemented in a plant. Okay, planting control systems. So in this plant which performs the raw inputs and whatever the operations which is performing, these are the materials which is inputs which is taking our outputs which is coming. Okay, so from these inputs the plant which performs and then process reaction every time, the predefined time which is mentioned, for example 2 milliseconds of time or 2 minutes of time. So similar to that given requirement, the plant output and then the variables whatever which is there, it will be checked. Process reaction, it will be checked, and then product will be comes out from the plant. So this is the whole thing operation. Here in this process reaction we are checking it. Okay, we are checking it whether it is producing a correct result with a correct time, it's producing everything, it's checking. So it means the quality measurement, is also checking. So in the computer which performs the operation, if it is not, then the information, the required appropriate parameter need to be changed, that input will be fed into the plant. So this is the basic operations of the real-time applications. Okay, and this is the diagram which shows both the feedback and also a feed-forward loop. Okay, and so the first digital computer developed significantly for the real-time controls were for airborne operations, and in 1954 a Digitrack digital computer was successfully used to provide an automatic flights and weapon control systems. Okay, so these are the histories. How the real-time operating system which works now, so earlier how it was, so those things we are discussing here. Okay, and the applications of the digital computer to industrial control begins in the year 1950s, and the first industrial installations of the computer system was in September 1958. Okay, industry installation which was started in the year of 1958, when the power and then light company which has installed a day-stone computer system for the plant monitoring at their power station. Okay, and the first industrial computer control installation was made by the Texaco company, who installed that particular system RW300. So this is the system at the airport in Texas. Okay, So histories, these are the histories. And 1958 to 1958, 57 to 58. So that is one of the chemical company. In that chemical company, in cooperation with the Ramo Woldridge company, they studied the possibility of using the computer control, and in October 1958 decided to implement the scheme on ammonia plant. Okay, so this is the one of the company. So that company it's decided to use the computer controlling system in chemical plant, and then same system which was installed by the PF Godrej company on their plant, okay, in the year of 1959 to 1960. And the first digital, I mean the direct digital control computer system that was implemented in the year of 1962. Okay, so that was the Fahrenheit Argus 200 system. Okay, so this is the one of the system. So that system which was installed in the year of 1962 November at the ammonia plant. So that is soda plant. Okay, so these are the systems. I will tell you what is a direct digital control system in depth when we are talking about the further topics. Okay, and the computers used in the early 1960s combined with the magnetic core memories and then drum store, and the drum eventually giving the way to the hard disk drive. Okay, and afterwards the attempts to resolve some of the problems of the earlier machine leads to an increases the cost of the system. So the system cost is increases. So the consequence of the generations of further problems, particularly in the development of software, increase in the size of the program meant that not at all code could be stored in the core memory. The provisions to be made for swapping the codes between the drum memory and then code. So already we have talked about in the operating system the swapping the programs. So some kinds of the ROM is available from the disk. Whenever it is required, we are changing the memories, because to increase the memory size we are going for the swappings and all. So the solution which is appeared to lie in the development of general purpose real-time operating system and the high level languages. Okay, and in the year of 1960s, late year of 1960s, the real-time operating system were developed and the various process photon compiler made their appearance. So the problem and then cost involved in attempting to do everything in the computer let's user to retreat to the smaller system, for which the newly developing the mini computer, okay, was to prove ideally suited. Okay, so these are the histories of real-time systems, and these are the references. Okay, I hope the introductions of the real-time systems and also histories of the real-time systems are clear for you. Okay, hope this video is helpful. We'll meet you in the next video. Thank you all.